Okay, so welcome to our first video. One of the rules for this video is as follows. I'm not going to get dressed up for these videos. I'm going to wear exactly what I wear when I work around the house. So I'm sorry I look grubby. I will try to stay out of your camera range. Don't make fun of the grubby clothes. Dogs may make an appearance every once in a while. That's a good thing. So I'm going to solve for you the aspirin problem that was on the test because about 35% of you had an issue with this. And this is an important skill to have, theoretical yield, if you're going to move on in chemistry. So what I've listed out for you so far are my reactants, my salicylic acid, 1 gram with its uncertainty. I also calculated for you the molar mass. Everybody calculated the mass of salicylic acid correctly of 138 grams per mole. Acetic anhydride. This is where people got tripped up. Acetic anhydride is not a gas, it's a liquid. And I gave you this hint here that you've got a density. So if you use 22.7 grams per mole, you were thinking that you had a gas, but you didn't. I'm going to show you how to use that density in a second. The acetic anhydride has a mass as well that we're going to calculate in a moment of 102 grams. That's the molar mass of acetic anhydride. And then I've calculated for you the molar mass of aspirin of 180 grams per mole. So I also listed for you the balanced chemical equation. 99% of you did this correctly. You all recognize that you have a 1 to 1 to 1 to 1 ratio here. So 1 mole of acetic anhydride will mix with 1 mole of salicylic acid to make 1 mole of acetylsalicylic acid. This is my aspirin, my ASA. We'll call this my AA for acetic anhydride. We'll call this one SA for salicylic. And this is going to be my acetic acid. We'll call it vinegar because we really don't care about it. So next step is to figure out the theoretical yield. So what I've got going on here is I'm going to start with salicylic acid. So 1.00 grams of salicylic acid over 1 times 1 mole is 138 grams SA times 1 mole of ASA, aspirin, goes to 1 mole of SA. I'm going to stop right there. I don't need to go to grams because if I can figure out the least number of moles, I only have to find the number of grams of the smallest one because that's the one that will limit the amount of aspirin I make. So that's my setup for my salicylic acid. Here's my setup for my acetic anhydride, and here's where the mistakes all came. I've got 3.00 milliliters of acetic anhydride over 1, and 1.08 grams of it is going to be 1 milliliter. That's how I go to grams first. So it has an extra conversion in there. Times 1 mole of acetic anhydride is 102 grams. And then I've got 1 mole of aspirin to every 1 mole of acetic anhydride. So now it's time to calculate these things out. Hold that thought while I get my calculator. So for my salicylic acid, I'm going to have 1 divided by 138. And with appropriate sig figs, which is going to be 4, I have 0.007246 moles of acetylsalicylic acid I can make. For my acetic anhydride, I've got 3 times 1.08 divided by 102. I get a lot more. I get 0.032 moles of aspirin from this one. So a lot of you at this step figured out that you thought that acetic anhydride was your limiting, because if you used your gas constant, you would have found that this was a lot smaller than this one. However, when you do it the appropriate way to use the density, my limiting reagent is going to be the SA, the salicylic acid, and my theoretical yield will come from the moles of 0.007246. So I'm going to take that 0.007246 over 1, and this is moles of aspirin, times 180 grams for every 1 mole, and 0.007246 times 180. My theoretical yield of aspirin with 4 sig figs should be 1.304 grams of aspirin. So that is step 1, the theoretical yield. I'm going to pause here just so